Hello everyone, I hope you can hear me. It's now 11 a.m. finish time, 10 a.m. Central Time, so I'd like to welcome you to this B4EST seminar on the Planter's Guide. First of all, a quick introduction. My name is Rach Colling and I'm from the European Forest Institute, one of the partners of the B4EST project. I'm your host today, really, I suppose, for this webinar. Firstly, just some quick housekeeping rules. This session is being recorded, so we can make use of it later on. Please, if it's possible, keep your microphone muted and your video off so that we all have enough bandwidth to use this. If you have any questions, please put them into the chat box or raise a hand, and then we can deal with these in the Q&A part of the agenda today. If you look at the agenda, you'll see we have a very brief introduction from me, a presentation from Mats Berlin from Skogforsk on the Planter's Guide. We'll have some live testing of the tool itself, and then we've got some time for questions afterwards. So first of all, just for those of you who don't know anything about the B4EST project, we are an EU-funded H2020 project on adaptive breeding for productive, sustainable and resilient forests under climate change. We're taking expert knowledge from forest actors and generating new scientific information on tree species sensitivity and their capacity really to adapt to climate change. As part of this 4-year project, we aim to provide new and flexible, resilient tree breeding strategies and tools. And that's one of the things we're going to look at today, one of the tools that's been produced within the project. Just a brief look here. As you can see, we are a large consortium of partners, 19 in total. And if anyone would like any further information about the project, you can find us on the internet at b4est.eu. We also have a Twitter account that you can follow, and for any further information, please contact directly us on info@b4est.eu. So I'd like to hand over now to Mats, who's going to give us a presentation on the tool itself. So I'll stop sharing my screen now and ask Mats to take over.
Yes, I hope you can hear me, and I will try to share my screen now. So I'll take this. So the first part is a presentation about the Planter's Guide, and then we will have a demonstration of the way it works. And very briefly, I am normally a tree breeder at Skogforsk, but my research part of my job has been to work with climate adaptation, and in particular these kind of decision support tools for improved forest reproductive material. So, and I'm also work package leader in B4EST dealing with these kind of questions within the project. So first of all, I would like to introduce to you a background about the use and how we use improved forest reproductive material and what it is in the Scandinavian countries. So the first thing to know is that forest reproductive material, a large part of it is genetically improved, what is actually used out in forestry in both Sweden and Finland. I have a graph here showing how much of the planted seedlings that originates from Swedish seed orchards for the 2 big tree species in Sweden, that is Norway spruce and Scots pine. They are more than 95% of the planted seedlings in Sweden. So as you can see, for Scots pine, almost all of the seedlings originate from seed orchards, which are then genetically improved. For Norway spruce, the graph was going the same way until a couple of years ago, when it dropped, and it has nothing to do with lack of interest in using these improved material. It is simply a lack of supply of improved seed that has produced this graph. However, this year we had a good flowering of Norway spruce seed orchards, so we expect this graph to grow up. But the thing is that we are using a lot of genetically improved material in our forests today, and will continue to do so. Almost exclusively, all improved forest reproductive material when it comes to Norway spruce and Scots pine in Sweden and Finland originate from seed orchards. There is a very small amount of plants coming from cuttings, but that's just about, if you look at the numbers here, you can see that we're talking about over 300 million seedlings per year. I think about 1 or 2 million of this material comes from cuttings, and only for Norway spruce, so it's a very small amount. So most of the improved forest reproductive material originates from seed orchards. Now, these seed orchards currently have very different levels of genetic gain. This graph shows the estimated increase in per hectare production for the 3 different kind of seed orchards that we have available today. The first one, which is called ETO, is the old seed orchards established in the 60s, which have about 10% gain in per hectare production. The second round came in the 80s. That is a bit of the material has been genetically improved, but not so very much. It was much to do with a new plus tree collection, and that has about 10 to 15% gain. But the big thing is that the 1.5 generation seed orchards are now starting to be productive, and they are producing genetically improved material, which has an increase in gain around 20 to 25%. So that's a big difference now in the genetic gain for a seed orchard. So seed orchards are very different in that respect. But they are different in other ways too. They are adapted to different combinations of temperature and light conditions, photoperiod, because these are the 2 main drivers for performance of Scots pine and Norway spruce in this region. So the graph you see at the right represents the different colors represent different seed zones, which are these combinations of temperature, climate, and light conditions. So a lot of different zones actually for Scots pine in Sweden, and the same goes for Finland. However, climate change, we know, affects both performance of Scots pine and of course the deployment zones, as they are adapted to these different combinations of temperature and light. I mean, light conditions will be fairly similar, but temperature conditions will not. So the graph here shows just one of the climate variables we know is very important for the performance of Scots pine and Norway spruce in this region, which is temperature sum, accumulated temperature during the vegetation period. So as you can see, the temperature sum for the current climate is on the left hand, and expected temperature sum 2050 is quite different. You see the effect of global warming there. So all of these things combined has put pressure on and the requirements to produce decision support tool for Swedish and of course also Finnish forestry. So this background has then boiled down to a number of objectives which we are pursuing in the B4EST project. So first of all, we are intending on taking this climate change into account by using climate variables and scenario data in a smart way when developing the second point here, which is developing these new transfer effect models. So they should take this climate variables into account and be able to handle scenario data. And this is not enough. We also want to implement this knowledge which we are developing into new and modern web tools, easily accessible and freely available. And also we want to work towards regional joint models and deployment platforms. Climate change does not recognize administrative borders like country borders. It works on biological areas rather than these administrative. So this is one of the aspects of the projects, to go beyond these administrative borders. So there have been a number of steps within this this bigger picture, this project. So the first step was to develop a new Swedish version of this planter's guide tool for Scots pine, and that was done before B4EST. So within B4EST, we have been working on developing the joint tool and all that comes with doing that. And we're also working towards a joint tool for not only the Sweden and Finland, but a bigger Nordic and Baltic planter's guide tool for Norway spruce. But in this presentation, I'm going to focus on this joint Swedish-Finnish planter's guide tool for Scots pine. But just some background about the project. So how has this worked during the B4EST project? There's been a lot of field data and climate data used for developing these models. On the picture here, you can see the left hand are the trial sites, and the right hand, the B graph there, is the different provenances or origins of genetic entries that have been used in the modeling. And then just as a demonstration of the climate data, I have this temperature sum as well. So climate data and all this field data has been compiled and prepared. And then models have been developed which are then valid for both countries. In this case, the two main traits of interest are growth, which is the left graph, and survival, which is the right graph there. Those are the two main characteristics that we are interested in developing models for Scots pine. Also, a very important part has been to coordinate these kind of seed orchard characteristics so that they are described in a similar way, so that they can be compared on a joint platform. And this also includes incorporating national rules and legislations. That's been quite some work to do that. And then finally develop this transnational, or Swedish-Finnish in this case, deployment platform, which has then been implemented into the planter's guide tool. So just a couple of notes on this work. Our experience is that collaboration with climate researchers is key in providing this kind of combined climate reference data and climate scenarios and how they actually affect tree performance. So we have been establishing collaboration with climate researchers since quite some time, many years ago. It's also very important to have collaboration and feedback from stakeholders. We have had quite a lot of feedback from stakeholders when developing, in particular, the design of the web tool. I will come back to that a little bit later, but that we have found is quite important to have this collaboration. And I would also again like to stress the fact that we are working on the same modeling effort like we did for Scots pine, but for Norway spruce and in a slightly bigger region. And we are also working on including effects of abiotic and biotic risks in a more detailed way. And we are also working with how to handle the uncertainty and risk of the variability that arises from different climate scenarios, and also a little bit of modeling uncertainty. So given that, we have developed this tool called the Planter's Guide. It is available at the link that you see there, that web page. It was released in September this year, the Swedish-Finnish version as an operational tool. These versions are then in Swedish for Sweden and in Finnish for Finland, and those are the operational tools that are supposed to be used by end users. Then you have also an English version, and that's the one I'm going to show to you today, which is mostly done for demonstration purposes. You can of course use it if you prefer to have this tool in English, because it works the same way as the operational Swedish and Finnish tools, but it's mostly for demonstration purposes. And it is openly available, so you can just go into that web page and find the tool and use it. So how does this tool work then? It works in a very simple way. It works in the way that you use Google Maps as a background for selecting sites. So you can either go and put in the coordinates of the regeneration site that you want to have recommendations for, or you can actually click in the map and select the site. As you can see, when you click, you will have a red square in behind, and that's the climate grid. And I will talk a little bit more about that when we demonstrate the tool. But anyways, it should be easy to use. When you do that and you click the button Show Recommendations, you will get a list. You will get a list of seed orchards, and they are shown and ranked according to the predicted aerial production over a rotation, a so-called production index. And that's the column where the arrow points. It's called index. However, both growth and survival are shown separately for selection purposes, which I will also demonstrate when demonstrating the tool. They are called sur and grow in the columns just right to the index column. In this tool, you can also select a climate scenario. However, currently we only have one scenario. That's one of the things that we will develop within the B4EST project. But you can also adjust for local climatic conditions, and that relates to the size of the grid, and I will also demonstrate that when we look at the tool a little bit later on here. You have local stand performance given as a reference. So in this case, if we assume that we have natural regeneration and do not use improved material, you will have the performance given by the first row in gray here. And we have set that as a relative value. So 100 is the relative value of the local origin, which works for growth and for the production index. However, for survival, we have survival in percent. So 81.8% would be presumed to survive for a local origin at that site. And then the performance of the seed orchards for those relative assessments are given relative to local stands. So for growth and for the production index, we have a number, which means that in this case, for the production index for that first orchard, we have 120. And that means that this orchard is assumed to produce 20% better, more growth, more volume production than the local stand at that particular site. So that's the basic way that the tool works. We also provide deployment maps for each seed orchard. However, they are displayed in a way that is related to the tool. So for this orchard in particular, you can see the deployment area of that orchard, and it has a color scale. So it relates to this relative measure of production. So a darker green color means that it outperforms local stand more than if it is a light green color. So one can see where this orchard performs less or more or better, more or less better than the local stand. And it is also done like this to be able to compare different seed orchards to each other when you have these maps side by side. So we will also have a look at this when we look at the tool. And some final notes, just the deployment recommendations, which are the background or the platform for this tool, are also available at that link which I'm showing here. So having gone through the background of the Planter's Guide tool, I would now like to stop share to show you the tool itself. So when you go into, when you click on that link, which is given on the presentation, or if you just search for Planter's Guide, you can find this English version, Planter's Guide Pine. You have some background information about the tool itself, and then you have a number of things which I think are quite important. This called FAQ is the frequently asked questions. This is the feedback, one of the ways to handle feedback from stakeholders and end users. And in this case, if you click on that, you will have a number of questions that have been considered important by end users, and we have tried to answer them as good as possible. And this is a living document. This will be changed after more comments have been obtained by us. So this is one of the ways we have handled the stakeholder feedback. The other one has, of course, been to do design changes when relevant. So the other thing is that there is a background description of how this tool works in a more detailed way. So that's the working report, which is here, which describes the deployment recommendations and how they have been derived. So this is a lot of theoretical background. I'm just going to about the models and about how the climate adaptation has been done and how you calculate different things for the seed orchards and so on. A very detailed report. So you have all of that compiled here if you want to learn more about how the tool works. Now let's go down then, and you can see then you have this map, and you can zoom in this map. And I have actually selected a specific site for demonstration purposes here in Sweden. But you can see if you just take this selection part, you can drop it there. That's another selection, or there. And you select a regeneration site. However, I want to select this particular site that one for demonstration purposes. And as you can see this climate grid here. In this case, it's 4 by 4 kilometers. And the grid size is a trade-off between having as high spatial resolution as possible for the recommendations, but also at the same time to provide reliable climate scenario signals. And then after long discussions with the climate researchers, we have settled on for the time being that resolution. But that has some other effects which I will come back to a little bit later. But we can zoom in as much as possible, and you can see now that we have selected a given site within this grid. I mean, you can select this site, but it will still be the same grid. So that's the way this system works. And I will come back to the effects of that a little bit later. But okay, let's say we want to establish a regeneration at this site. So let's click Show Recommendations. And then you get some basic information about the site. You get the altitude above the sea level. And you get also an estimate of the temperature sum at that site. And you have these information boxes here, so you can always look at the different parts of the tool, and you can get some information about what every well, in this case, what does that mean? What does temperature sum mean, and so on. So if we just look at the results here, you can see that we have then a number of seed orchards. As you can see, we are in Sweden, and the first and the best seed orchard at this site, or the highest ranked, is a Swedish seed orchard, Västerhus. But then you have a number of Finnish seed orchards which are actually performing quite well at that site. If you look quite carefully on the two best seed orchards here, both of them have an estimated production index of 120. But if you also look at the two other columns, survival and growth, you can see that this estimated production is very different for the two seed orchards. In this seed orchards, you have a higher survival, you have a hardier material, but its growth is a bit slower. On the other hand, this seed orchard has a very high growth, but a little bit less survival. However, both of them are combined into the same estimated production over a rotation. But this has been one of the things that end users has required. They have required that we should also be able to sort or rank the seed orchards according to either of these two specific traits. So for example, I could sort the seed orchards on survival instead. And then you will get very, very hardy material here, which has a very high survival. But then of course you will have less production. So you can also sort them for just growth, and you can have the seed orchards which are very high in growth here. But as you can see, survival of the two first ones is quite low. So our default setting, is, I'm just going to, there we go, we're back here. So our default setting is to have a ranking according to the estimated production over a rotation, which is a combination of survival and growth. But you have the opportunity to actually select one of these traits separately. And that's been a requirement from the stakeholders and end users actually. At this particular site, I'm just going to go back very briefly again. At this particular site, you can see it's quite hilly. So, and the models are based on the average performance within this grid. So of course, there could be a variation within this grid. And we are currently working on research how to use topographic indexes and so on to get this estimate a little bit better on how to do this local climatic adjustment. But for now, we know that there could be in particular places in Sweden, specifically in these hilly parts, there could be a local climatic difference between the average value of the grid and the actual regeneration site. So if we now assume, and then you can go into adjustment for local conditions, and you can see there's a lot of explanation there. There's more explanation in the FAQ on how to use that. But for example, if we assume that we are planting on a northward slope, we might expect the conditions to be harsher than the average grid. So we could select harsh here. And I'm just going to point out to you the situation here. You look at the seed orchard ranking here. You have the first one is Västerhus, the second one is Suhola, and then you have a number of Finnish seed orchards. And look also at the estimated survival. So what happens when I, in this particular hilly parts of Sweden, select a harsh site instead? You can now see that survival dropped like 6 percentage units here by selecting a harsher site. This is in particular true for these hilly parts where you actually have differences within the grid cell. So the first orchard is still the same, but the Finnish orchard, the one that was second earlier on, is now down here because that was very high growth, and you can see that survival has dropped quite heavily. So in this way, you can introduce this kind of variation, and you can have, as an end user, some control of how you want to select your seed orchard. So in this case, when you have this, when you know that local climatic conditions are very important, you can use this to find the best material for your purposes and introduce some kind of risk aversion in some sense. But if we look at, I'm just going back to the average value here again. So we can look at these two orchards. We can just click here and here, because we can select one or several seed orchards for comparison and try to understand why they behave differently. So we can go down to this button here, which says compare selected orchards, and we can click on that. So what happens now is that you see the deployment maps of these two orchards side by side. And as you can see, that orchard, which was a more hardy orchard, performing better in a harsh climate, I can point with the arrow here that we're planting somewhere here. And as you can see, the second orchard is really on the limit of where it's supposed to be used. It's around here. It's still performing well, but you can see what happened when we just selected the site to be a little bit more harsh. It was dropping fairly quickly. So in this sense, you can use this comparison between the orchards to understand more about the characteristics of them and understand a little bit more why they are performing differently at different sites when you do these adjustments. So going back again, if you just want to know something specific about one of the orchards, you can also click in the orchard at the orchard name, and you will get the same deployment map, but a bigger one, and you also get a lot of information about the orchard. Some administrative information, when it was established, detailed information about the clonal material in the orchard, and also who owns the orchard. So you can find more information about a given seed orchard by clicking on it also. And you can also select to have only orchards from either of the country. So in this case, I'm situated in Sweden, and maybe I want to look at only the Swedish seed orchard, and you can do so. And then you have only Swedish seed orchards. And of course, you can do the similar operation for Finland. However, as default, we are showing all of the orchards because, again, we believe that this could be a platform for increased trade and more optimal use of seed orchards across Sweden and Finland. So in some parts in Sweden, the 1.5 generation seed orchard development or establishment is slower than in Finland, and vice versa. So in some parts in a transient time, we will have better material from our neighboring country than what we have within the country. So this may open up for the possibility to use material from neighboring countries. So this is a first step in providing this kind of platform. I just also wanted to show you that you have the opportunity to show all the orchards. In this case, we only show, I think it's 8 or 10 best ones. And then if you want to see them all, you can click on this and you can get all of the orchards. I mean, maybe it's not possible to get seed from the best, or seedlings from the best orchards. You have to ask your nursery about that. So you may want to go down a bit to see other options for seed orchards, but the list grows quite quickly and becomes a big one. So that's why we have oh, I need to go back here. Let me just do that so we can come back to this structure. So that's why we have cut it like this, so it's easier to use, because we have the opportunity still to use stand seeds. And in this case, we can click on that and you can see how stand seeds perform. So in this case, the site was quite mild. and you will not gain very much from transferring stand seed. In this case, you can see this is local origin, and you could have a very slight northern transfer and get the same performance. But at sites which are quite harsh, you could use, in this case, Scots pine stand seed and get an improved performance, an index above 100, because they will be more hardy for these harsh conditions. But in this case, that's not an option. But this is because in some senses stand seed is still used. So we want to have this opportunity for the end users to look at the stand seed as well. I think that is the main demonstration that I wanted to do with this tool. So I think I am finished with the presentation, and we can start the Q&A part of the webinar.
So if anybody has any questions for Mats, please raise your hand or type them in the chat box and we'll do our best to answer them. I've got a question from Christoph for you, Mats, that says, what is the actual practice regulation on the use of improved material?
There is the actual administrative regulations are built into this tool. So you have the biological models, but then you have a mask that works with the actual law as well. So but it's mostly not limited by the law, at least not in Sweden, because that's a very wide the transfer is allowed quite widely in Sweden, but the law has been, the administrative regulations has been built into the tool. This tool is mostly used by, in this case, smaller forest owners, because you have to select one site at the time. So there is another tool in development which is supposed to be used by larger forest owners, like forest companies, which can using several hundred sites at the same time. But it's still the same model platform. It's just another graphical user interface.
Thank you. Any other questions from anyone?
Could I ask a question? Hello?
Yes.
Yes, this is Tore Skarpa from Oslo, Norway. Thank you for a very interesting presentation, Mats. Could you give a little bit more information how these predictions, the productions, the different seed orchard materials were generated? And what about the uncertainties? Are there any kind of confidence limits for these predictions? I'm thinking about the transfer function developments. Are they based on progeny tests, provenance data, whatsoever? Thank you.
Yes, that's a very good question. There is a paper that describes how the models have been produced for Scots pine. We can probably add this to where this webinar will be put later on. The models are based on provenance or checklot stand, natural stand data, due to the fact that they have this spread in both climate and sites, which is necessary to get these reaction patterns. However, in order for the models to be valid for improved forest reproductive material, we have used progeny data and also used both the plus tree, the phenotypic selection data, but also the data from which of these genotypes were actually genetically selected. And we have used them as a validation part of the model. So we put them into the model and look at the residual analysis of the model to see if there's any systematic differences and to see if we have changed the origin synthetically by selecting genotypes for a certain area. So the first part, the phenotypic study has been done, and we have seen that these models are valid for phenotypically selected genetic entries. So they are valid for the first round seed orchards. But we have also just recently finalized a study about genetic selection, and we see that these models are actually holding for that kind of material too. So they are working for the 1.5 generation seed orchard as well. Regarding uncertainty, that's right. We have not yet done a sensitivity analysis of model coefficients. We will do that in the B4EST projects. We have also not introduced the variability which arises from different climate scenarios, both within and between climate scenarios. And those kind of uncertainties will be introduced in this tool when we have the research results from the B4EST projects. I would say in 2 years' time, maybe, they will be introduced into this Planter's Guide tool. But we do not have these results yet.
Thank you.
Thank you. Any more questions from anyone? I can't see anything else in the chat box, and if nobody else has any further questions on this, it just remains to say thank you very much to Mats for the presentation. We'll make this recording available online on the B4EST website, and we'll also put there Mats's presentation. If you want to go back to it again, we'll also post that there, and any further links. So for example, to the paper he was talking about, we'll drop that all into the same space. So thank you on behalf of B4EST to everyone for attending. Thank you very much.
Thank you.